Okay, let's build one of these 2399 triple splashback delay modules. This is what it's going to look like when it's done, and I'd say this is a good project to do even if it's your first time soldering, because most of the components are already on the board. They're these little SMD ones that get soldered on by robots, so all you got to do is add a few more things and you've got your own complete module. If this is your first time soldering a module together, there's a link down below to the Adafruit Guide to Excellent Soldering, just to help you along. So let's briefly talk through the components that you're going to need to source. They're all pretty normal available components that you can get off of websites like DigiKey or Mouser or Thonk, and you can even get some of them off of places like AliExpress or eBay, which is going to be your cheapest option for little things like the header here or even the LEDs. Down below there is a link to the bill of materials, which is going to tell you exactly the specification of the parts that you need, and there's even links in there to some retailers, but best to shop around. They're just to give you an example. So first off, let's take a look at the switches here. We have one single pole double throw switch. So that means that it's a single-sided switch that switches this middle contact between this right side and the left side. You'll see it called SPDT, single pole double throw, and it might be labelled on. That's because as you move the switch, this is on, connected to this side, and then you press it across and it's on, connected to this side. There isn't a middle position. Some of them have an off position in the middle. They'll be called on, off, on. This is just on. And if we look at the double pole double throw switch, you see that it's just basically two of these side by side in there. Exactly the same on, but there are two rows there. And very important that you get the sub-miniature switches with these pins on the bottom. These are the miniature switches, and you can see a fair bit bigger. You don't want the miniature, you need the sub-miniature. And of course you're going to need the nuts for those. Now you can use whatever knobs you like really, but we like these little Rogan knobs for the 9 ones here, and for the top knob we've got this SCI knob that is available at Rapid Electronics in the UK or Tader elsewhere. Next up, let's look at the potentiometers. These are vertical, all of them B100K, that's linear, 100 kilo ohm, 9mm alpha, 6.35mm round shaft potentiometers. We've specified that type of shaft because that's what fits with the knobs that we use, but if you're going to use different knobs, then you need to get the potentiometer shaft that's going to fit with the knobs that you want to use. Those also obviously need their washers and nuts. We have 3 of these 3.5mm mono jacks for Eurorack cables like this, and they also have nuts. We like these hex nuts, but you can use whatever you like. We have 5 3mm LEDs. The ones that we like have this domed round top, and they are diffused and light up red, but we'll leave the choice of LEDs up to you as well. And last but not least, we have the header for the power ribbon cable. This has 2 rows of 5 pins, so it's a 10-way, and it's shrouded, which means it's got this plastic cover around it, which means that you can't plug the ribbon cable in the wrong way. Put the panel to the side so that it doesn't get damaged, and make a bit of space for ourselves to solder in the first component, which is going to be the power header, and that goes on the bottom of the board, so you need to turn it over and you'll see the symbol for it right here. The header has a notch in it, and you can see that on the silk screen here as that notch, so that has to go around this way, and it sits in there with the legs poking through the holes to the other side. Then you want to just lower it down on the desk, making sure that it's still through there, and solder it in. So you want to touch the soldering iron to the leg and the pad, heat them both up, and as you're doing that you can kind of press down to keep the PCB level with the header underneath, and then as it heats up here, I'll show you, you can flow a little bit of solder in, then swap your hands over with the solder and hold the PCB level as you pull the soldering iron away. That'll keep the header flush until the solder cools, and then after you've done one joint it will hold itself on there, and you can then go ahead and do the others. And little tip, it's easier to have the soldering iron coming in from the outside and then flip it round and do the other side, if you see what I mean, because if you're trying to do this pin from the middle, then you might be heating up the solder that you've already flowed onto this pin with the back edge of the soldering iron, and then you're bridging pads and it'll get messy. So easier to attack it from the outside. Some pads are a little bit harder to solder than others. That's because they're connected to the ground plane, so that means that more of the heat from the soldering iron is getting sunk away, so you need to just hold the soldering iron on there for a tiny bit longer to get that heat into the pad and the leg of the header, and it will all flow in there fine. So if you're having trouble, just hold the soldering iron on there for a couple seconds more and you'll be sorted. There we go, the header is now completely soldered onto there, and all of the other components that we're going to do are going to be placed on the front of the PCB here. That was the only one that we had to solder on the bottom. So the way I like to do this is we plop all of the components in, then put the panel over, and then solder them on the back. That just means that all of these things are going to be lined up perfect with the holes in the panel before you solder them in. Otherwise you might solder them and they're a bit wonky, and then you're stressing the solder joints trying to get them through the holes, which is not good. So since the pots hold themselves in very nicely, we're just going to plop all of those in, and since all of them are B100Ks, you don't have to worry about getting the right value in the right place. They're all the same. So just pop them all in. We've got the three little legs here, plug them in first and then lever it down and pop these little side lugs into the bigger holes, and then they'll hold themselves in. You can just kind of wiggle it side to side to get each of those in, and then there you go, they will hold themselves in. There we are. Now we're going to do the same with the pots. They also hold themselves in quite nicely. A good way to do it is get the outside little ground leg in there first, then kind of maneuver the next closest leg into its hole, and then you can wiggle it again to line up the third one. Once they're all in there, just push it down with some even pressure. It'll even clip in there and it'll hold itself in nice. Okay, so now we're going to move on to the switches. The switches come with two nuts, and we're going to set the height of the first nut so that it's sitting exactly at the level underneath the panel. Okay, so that's the same height as the flat bit on these potentiometers, the same height as the flat bit that the panel sits on these jacks. Let's do this double pole one first, since it's the easiest to judge, since it's in this corner here, and we can compare it to the height of the jacks and the pots. So let's just roll this on down till, and you want this to be sat flat on the PCB. That's so you've got enough of these legs sticking out the backside to solder onto. So just look down at here and judge when that's on enough. I think that is about it right there. So then we can use this to set the other jacks, and then we'll be good to go. Okay, so the PCB is going to be here and the panel is going to be here. And do watch out, because the different type switches might have slightly different size nuts, so you don't want to mix those up. Right, so pop those in. It doesn't matter which way round they go, but they're not going to hold themselves in like the jacks and the pots did, so you're going to have to kind of balance them while you pop the LEDs in. Now the LEDs have to go in the right way round. There is a short leg and there is a long leg. The long leg is positive, the short leg is negative, and there's also on some LEDs a flat kind of side that you can feel on the actual bulby bit of the LED. That is on the short leg, that's the negative side. So on the silk screen, if you look at the LED symbols here, which are denoted by D, because LEDs are diodes, so it's a D, they get a D number. There's a plus next to the circular pad. That is the positive side, so the long positive leg needs to go in the circular pad, and the negative one goes in the square pad. All of the LEDs are the same way round, so as long as you got your wits about you, shouldn't be able to mess it up. You must get them the right way round, otherwise they are not going to work. Okay, so just pop them all in there and make sure they're all the way down on the board for now, and one more down here. Okay, so we got everything there. Now we're going to place the panel over it all. It can be a little bit fiddly, but you might need to get underneath and just wiggle the switch so it goes through. Then just making sure everything's lined up with its holes, and plop it on down. There you go. So everything's now seated perfectly. You've got a uniform gap between the PCB all the way around. Check that the nuts on the switches are the right height, so you've got the legs poking through enough to solder. Now you can put it on the side and it will stay there while you grab the nuts and washers for the potentiometers. Let's put a washer over this top one, and then put this on down, screw it on a little bit, repeat that for all of them. Cool, and I use one of these little deep sockets. This is a 10mm one, just a little bit longer, so they go over the shaft of the potentiometer there, and you can just tighten it down. It doesn't need to be that tight, that's why I'm not using the actual ratchet tool, I'm just doing it by hand, because you can damage the component by over tightening it. Just needs to be enough that it's solidly on there. And the advantage of this tool is that it's really quick, and if you're using pliers to do this, it's very, very easy to scratch the panel. This totally avoids that. Now let's get the nuts for the jacks on there. Tighten them up as well, using a 8mm socket for that, and the little nuts for the switches too. You can also use a socket for those. I've got a 7mm. There you go. But just be careful, because these ones don't have washers around, so just don't push the socket down too much. You might again scratch the panel. Okay, so now that everything's on there really secure and you're sure that the PCB and the panel are pressed together nicely, you can angle the LEDs through their panel hole. You just grab them on the back, maneuver them around so that they line up, and then poke on through like that. Make sure all of them nicely through. Last one there. So make sure they're all through, and then you can gently turn it around, place it all on the desk, and solder everything in. I'd start with the LEDs first, because you don't want to risk them accidentally moving and you're not realising, and then you solder them in the wrong way. What you can do if you want to be extra sure is solder one leg of the LED, check it, make sure that it's positioned right, then solder the other leg. That way, if it's wrong, you can just reheat that one joint and move the LED. Way easier than desoldering two. And remember, some of the pads, they are on the ground plane, so they take a little bit more heat to solder. And what you could do is actually just flow a little bit more solder in periodically. It just gives it a bit more flux. Most solder these days has some flux inside it, which helps the solder flow a little bit more. There we go. It's all soldered on. So now, by the way, throughout the video, you've probably heard a load of tooting on the pipes. That's Look Mummo Computer in the background, testing his machine for the YouTube Secret Santa. Just so you know. So next step, we can clip off the legs of the LEDs here. A good tip: if you cut them a little bit further down on the snippers, then they won't ping off. You'll actually be able to grab them. Whereas if you cut them further up, yeah, they ping off, sometimes into your eyes, which is not so good. You might want to just brush that over to get rid of a bit of the excess flux that's sitting on the board, only so it looks nice. It doesn't actually make that much of a difference. And then the only thing left to do is to put the knobs on. Good way is to turn them all the way down, and then it's going to be about 7 o'clock. There we go. Awesome. Now we just got to test it and make sure it all works. If you've got any problems with it, majority of the times it's just a bad solder joint. Maybe you've even missed a solder joint. So go through all of those, reflow them, make sure everything looks good. Refer to that Adafruit Guide to Excellent Soldering that's linked below. If it's not that, then make sure you've got everything in the right way, like the LEDs around the right way, and make sure that that flat side is where the negative leg should be. Make sure that all of the legs of the components are actually sticking through. Maybe accidentally one of the legs of the potentiometers has got bent up and is not soldered in or something. It could be anything like that. And make sure that you've put this header in the right way. It won't work if the power is round the wrong way. A little bonus, I'll show you how to make your own ribbon cables, because it's a bit silly buying them, to be honest. They're much cheaper to just make yourself. So I'm going to get some of this 10-way IDC cable, ribbon cable. You're going to get a 10-way header for it, and also a 16-way header. Cut yourself a length of ribbon cable. I'd normally just use normal scissors because the jaws on these clippers are too short to do the whole cable in one go, and you want to get it nice and straight across. There you go. And then an important thing is to get these around the right way so that you know which way to plug the power in on the back of your module. On this one side of this ribbon cable there is a red cable, and so that is the minus 12 volts coming from your power supply. So you want that red to be lined up with this little arrow. Can you see that just on the plastic there? The little arrow. The red should be where the arrow is. So it goes through here and just line it up with that. And the red is where the arrow is. Just pinch it down a bit so it holds itself. Then you can put it in your crimping tool. This is a proper IDC crimping tool, but you don't have to go for one of these tools. They're about 20 quid, I think. But I got one because I make these all the time, but you can just use a vise. I did that for years. Just put that in there then. Make sure it's seated in there and that the ribbon is where it should be, and push it down. I'll crimp it in there, and there you go. That's all secured in there now. And you just do the same on the other side, again making sure that that little arrow is where the red is, so that needs to flip over. It goes through there to the side with the arrow there. Push it down. There we go. Just make sure that the ribbon is all the way over, so it's lining up with the correct pins on the bottom, if you see what I mean. And there you go, you have yourself a ribbon cable. The two headers should be pointing in opposite directions. Double check that the little arrow is on the red side. There you go. So I hope you enjoyed making this module. Thank you very much for buying yourself one, and check out the other modules in the range in the link below. Hopefully I'll see you again for another DIY build video.